Hello, this is part 2 of the 5.1 Fundamental Trig Identities. In this video, what I want to cover, I want to go over some of these identities with you. We have your quotient identities, which include tangent is equal to sine of x over cosine of x. And then because cotangent is the reciprocal of tangent, it's equal to cosine of x over sine of x. We use these identities in chapter 4 pretty regularly. We're also going to be taking a look at your odd and even identities. We've got, recall an even function. If you have a positive value of x and you put in a negative value of x, you get the same output if the function is even. It is symmetric about the y-axis, and odd functions are symmetric about the origin. And if you input a positive value of x versus a negative value of x, you get exactly the opposite. So a quick example of an even function is y equals x squared, because if you square a positive 3, you get 9, and you square a negative 3, you get 9. You get the same output regardless. And an odd function would be basic odd function is y equals x cubed. If you cube 2, you get 8. If you cube negative 2, you get negative 2 times negative 2 times negative 2 is negative 8. You get exactly the opposite output. So we have two even functions. They include cosine of x and secant of x. And so because they're even, if you have cosine of negative x, it's exactly the same as if you are finding the cosine of positive x. And the same holds true for secant. Whether you put in a positive angle or a negative angle, recall that positive angles go counterclockwise. Negative angles are clockwise angles. You'll get the same exact output. So those are both even identities. We have sine of negative x is equal to the exact opposite of sine of positive x. So those two would be, for example, sine of pi over 4 is the square root of 2 over 2. Hopefully you remember that. And the sine of negative pi over 4 is negative square root of 2 over 2. So they're exactly opposite outputs. That holds true for sine, cosecant, tangent, and cotangent. So the only even functions are cosine and its reciprocal secant. The rest are odd. Okay, so cofunction identities. Cofunction identities, that means with, so it's like the function that goes with the given function is kind of how you can remember it. But if you have the sine of pi over 2 minus an angle, any angle, it will equal the cosine of that angle u. So cofunction, so sine and cosine, they're the same exact graph but shifted. So they are the ones that go with each other. For cosine of pi over 2 minus u, it's equal to sine of u. And tangent of pi over 2 minus u is equal to cotangent of u. And so again, these are all identities, which means that if you see this, you can replace it with this. They are exactly the same. It's kind of like 1/2 is exactly the same as 0.5. They do not look the same, but they mean the exact same thing. So that's what an identity is. It can be, you could replace cosine of u anytime you see the sine of pi over 2 minus u. And u represents an angle here. Okay, cosecant is of pi over 2 minus u is equal to the secant of that angle u. Secant is equal to the secant of pi over 2 minus u is equal to the cosecant of u. And then cotangent of pi over 2 minus u is equal to the tangent of u. If you want to look at like how that would apply, if you were going to find, let's say you have the sine of pi over 2 minus pi, it would be identical, that output would be identical to the cosine of pi, because I replaced the u with a pi. And cosine of pi is relatively easy to find. Hopefully remember, think to yourself, what is the cosine of pi? it is -1. If you need to review that in chapter 4, you might need to go back or bring me some questions if you're like, I really would like you to show me how to do that. We can do that in our next Zoom conference. The cosine of pi equals 1. So that means the sine of pi over 2 minus pi is also equal to 1 because those are identities. Okay, now we're going to do an example. Example 1. We're going to use some of these identities and figure out if we know that the secant of an angle is -3/2, and it says that tangent of that angle, notice these angles are the same, is positive, find sine, cosine, cosecant, and cotangent. Okay, let's do a quick little review here. First of all, let's figure out what quadrant that would be in. So where is the secant negative, because it's equal to a negative output, and the tangent is greater than 0, so tangent is greater than 0, so it's positive. In what quadrant would that put you? So think about secant is the reciprocal of cosine. Cosine is positive in 1 and 4, it's negative in 2 and 3. So it's got to be in either 2 or 3, and then in which of those quadrants is the tangent positive? And that would be in quadrant 3. So in quadrant 3, we know that the sine is going to be a negative, cosine is a negative, cosecant is the reciprocal of sine, so it's also negative, and cotangent, reciprocal of tangent, has to be positive since the tangent is positive. Okay, so we've done problems like this before in other ways where we draw the angle and that terminates in quadrant 3. That's one method, and you can find the opposite, the adjacent, and the hypotenuse, given that the hypotenuse over the side adjacent is -3 and 2. Use a Pythagorean theorem to find the side opposite, and you can do it that way, or you can use these identities, which is what I'm going to do in this lesson because I want to review how the identities work and where you can use them. Okay, so since the secant is -3/2, and we know that the cosine of an angle is the reciprocal of secant, that one is relatively easy. You're just going to take the reciprocal of -3/2 and you get -2/3. Okay, so then we're going to find the sine, and in order to find the sine of that angle, you can use this identity, that sine squared of u plus cosine squared of u, equals 1, and that's the Pythagorean identity. We know that the cosine is -2/3. I'm going to square that because it's cosine squared, and I'm going to take this identity and I'm going to solve that for sine of u. So sine squared u plus, I'm going to square -2, which is 4, and square the 3, which is 9. You get 4 over 9. I'm going to subtract that from both sides because I'm solving for u. So 1 minus 4 ninths, I'm going to make this into 9 ninths minus 4 ninths is 5 ninths. And then that's what sine squared of u, that's what the sine of u squared equals. So now in order to figure out what sine is, you have to take the square root of both sides. And we know back up here it was in quadrant 3, it's going to be a negative result. So the sine of u, when I take the square root of something squared, it cancels out, is equal to the square root of 5, and it's negative, over the square root of 9. I can split that up. When you have a quotient, you can split it up underneath the square root, and that becomes negative square root of 5 over the square root of 9, which is 3. Okay, then to find the cosecant of the angle, we can simply flip that and rationalize, which would be 3 square root of 5 over 5. You can check that yourself. And then we also can find tangent of that angle, because we know tangent is sine of u over cosine of u. So this is using one of the quotient identities. And if sine is negative square root of 5 over 3, cosine is negative 2/3. Over here, remember that. When you simplify that, you're going to get the tangent is equal to negative square root of 5